In this video, I'll be explaining how to find the antiderivative and what indefinite integration is. So, say you were given the equation y equals x squared plus 10. The derivative of that would be y prime equals 2x. Now, when you go to take the antiderivative of something, then what you're going to be doing, there's 3 steps involved. And what you're looking to do is get from this equation back up to this equation. So the first thing you're going to do is raise the exponent by 1. Second step is divide by new exponent, and the third step is add c. However, this is for indefinite integration. So, say we were given y prime equals 2x. In order to find the antiderivative, the first thing we would do is raise the the symbol for find the antiderivative is that symbol right there. And then it'll be f of x dx. So this is asking, take the integral, find the antiderivative of 2x dx. So the first step is to raise the exponent by 1. So 2x, and then raise the exponent on the variable by 1. So 2x squared. Second step, divide by new exponent. So divide by 2. And then third step, add c. Now, the reason why we add c is because, like I demonstrated with this example over here, the derivative of y equals x squared plus 10 is 2x. However, 2x is also the derivative of y equals x squared plus 50, y equals x squared plus 100. So this c, this constant, is accounting for whatever this plus value would be. You know that it's going to be an indefinite integration problem if you're not given values right here and right here. So, like, as you'll learn in the following sections, definite integration is when, say, you'll have something like 1, 2, and then you'll have your function. But that's not going to be until a later video, so don't worry about that one for now. Back to our example, we can simplify this and cross out our 2's, and the antiderivative would be x squared plus c. So I'm just going to be running through examples in this video of just some basic find the antiderivative problems. Yeah. So, example, find the general solution of the differential equation y prime equals 3. When it asks for general solution, that just means indefinite integration. So, general equals indefinite. If it says particular, that means definite. Okay, so y prime equals 3. First thing, we'll just rewrite it to 3 dx. First thing, raise the exponent by 1. So 3x, we'll just say to the first. Divide by the new exponent, which is 1, and add c. Do some simplifying, and you get 3x plus c. Example 2. Take the integral of 3x dx. Or take the antiderivative of 3x dx. So first step, raise the exponent by 1, divide by the new exponent, and add c. Simplify, you get 3 halves x squared plus c. Next example, take the antiderivative of 1 over x to the third dx. Now, since there's no quotient rule or product rule when you're doing antiderivatives, you always want to look to look to make everything in a straightforward line, so as one continuous polynomial, I guess. So if I were to rewrite this, I could rewrite it as x to the negative third dx, and then you just do the same rules. Raise the exponent by 1, so when you raise it by 1 it goes to negative 2. Divide by your new exponent, which is negative 2. Add your c, and then when you simplify that, you get negative 1 over 2x squared plus c. The antiderivative of dx, that's just one that I would try to memorize because it's fairly simple, but that one just equals x plus c. If you think about it, there's no variable with no exponent, so if you go up one exponent, then you get x to the first divided by 1, and then you want to add your c. So take the antiderivative of x plus 1 over the square root of x. What I would do is just rewrite it, try to get it as a straight line. So x plus 1 times this square root of x can become x to the negative 1/2. And I forgot my dx on that one. And then from here, you can just simplify it even more. Distribute this x to the negative 1/2 across, so that you get x to the 1/2, x to the, plus x to the negative 1/2 dx. And now you just use the same rules and just go piece by piece. So x to the 3/2 over 3 over 2 plus x to the 1/2 over 1 over 2, and then plus c. That could simplify. When you simplify this one, you get 2/3 x to the 3/2, and when you simplify this one, you get plus 2 x to the 1/2 plus c. Take the antiderivative of sine x over cosine squared x. This one, since you can't move the cosine up, you could just, what I would recommend is splitting it up. So you go sine x over cosine x times 1 over cosine x. Because if you were to multiply these back across, then you would get the same thing as sine x over cosine squared x. So you get, take the integral of tangent x secant x, and according to that list of properties I presented in my last video, if you look at this one right here, it's secant x tangent x dx equals secant x plus c. Well, we have the tangent x secant x dx, and so the answer is just going to be secant x plus c. And final example, x squared plus x plus 1 all divided by the square root of x. Just rewrite it once again. So you have x squared plus x plus 1 times, when you move this square root of x to the top, you get x to the negative 1/2 dx. Go ahead and distribute these across. Remember that the exponents add up when you do that. So you're given x to the 3/2 plus x to the 1/2 plus x to the negative 1/2 dx. Go ahead and integrate each piece, and you get x to the 5/2 divided by 5 over 2 plus x to the 3/2 divided by 3 over 2 plus x to the 1/2 over 1 over 2, and then plus c. Do some simplifying, and you get 2/5 x to the 5/2 plus 2/3 x to the 3/2 plus 2x to the 1/2 plus c. Hopefully that all made sense. I'll be getting to definite integrations in a couple of videos, so with that you'll see this plus c disappear. But hopefully that clarified it up, and thanks for watching.